All right, we've talked about a bunch of different sequences like strings, lists, and tuples. Now we're going to talk about sequence operations, which is some stuff that you can do with sequences in Python. The first one is length. The length method allows you to determine the size of a sequence value. The result's going to be an integer. So take a look. We want to get length here. We use the len built-in function provided to us by Python. We can do it on strings, we can do it on lists, and we can do it on tuples. Now what you'll see is that we get a length of 4 on that string because we've got 4 characters here. And then we get a length of 3 on the list because we have 3 items here. Finally, we get 5 on the tuple because we've got 5 items in this tuple. We can also concatenate sequences together. To concatenate means to take 2 separate collections and put them together into one, with the order of the items preserved. So you can see examples of that here. When we do this on a string, a list, and a tuple, we can concatenate hello, world, and hello world together like this. We can do the same thing with 2 lists. We have a list that begins with A, and then we have a list 4, 5, and 6. When we concatenate them together with the plus operator, we get all of it together in one list with the order preserved. And the same thing with these 2 tuples. The order is preserved. It's worth noting that when we are concatenating sequences together like this, all of the sequences are of the same type. So we've concatenated 3 strings into 1 string, 2 lists into 1 list, 2 tuples into a tuple. We'll talk a little more about mixed operations later. Now, what would you think the multiplication operator would be used for? Some folks might believe, before trying it, that the multiplication operator would multiply all of the items in the list by a given integer. But that's not quite what happens. Instead, multiplication on a sequence produces repetition. Let's take a look. When we multiply the high string by 4, or our original list by 2, or this tuple by 4, we get 4 repetitions of high, 2 repetitions of our A list, and 4 repetitions of our 1, 2 tuple in one big sequence. Now let's talk about containment. Suppose you want to determine whether a given value is in your sequence. You can use the in keyword to do that. The result's going to be a Boolean telling you whether or not it's in there. So we can see if M is in the MPCS string, if T is in there, or if CS is in there. What you're going to see is that we get true for M, false for T, and true for CS. Similarly, for a list, we can make sure of what's in there by asking in is 4 in that list. Now remind you that that list looks like this. So 4 isn't in there. So we get false. But A is in there, and so we get true. And now we have this tuple, 1, 2, true, false, and high. It turns out the string Bob isn't in it, and the string 2 isn't in it. Now I do want to stop at this one for a second because the integer 2 is in there, but that's not the same type as the string that we're checking for right here. And finally, we check if 1 is in there. Now that one is an integer, so the answer there is true. Now let's talk about indexing. When you have a collection in which order is important, such as a string, a list, or a tuple, you can use an index to fetch an item from there. An index is an integer representing the point in the order that you want to get out. So let's take a look. We have this string called spam. Suppose we want to get the thing at the 0th index. We can use square braces like this with a 0. Our sequences in Python are 0 indexed, meaning that 0 gets the first item, 1 gets the second item, 2 gets the third item, and so on and so forth. So your very last index will be 1 less than the length of the list. So this should give us S. And the 2 index should give us what? 0, 1, 2. So it should give us A. And indeed we see here S and A. Now for lists it's the same. Suppose we want to get the first item in the list. That'll be A. How about the third item? That should be 1. And we see here A and 1. Now, let's take a look at tuples. In this tuple, we want to get the 4th item, 0, 1, 2, 3. That'll be false. And then the 3rd item, 0, 1, 2. And that'll be true. And we see that here. False and true. Now finally, because lists, unlike tuples or strings, are mutable, we can also use indexing to update the elements. Now we tried this earlier with the tuple and you'll recall that it failed because a tuple is immutable. But when we take our list and we reset the first item so that it's no longer the string A, but rather the integer 3, that updates our list so that the first item is now 3. Now suppose we wanted to make the second item the integer 5 instead of the string B. We can say list at index 1 should be equal to 5. And by doing that, assign the integer 5 to the second value in the list, as you can see right there. So we can use indexing for fetching or for assigning in lists, and we can use the index for fetching in strings and in tuples. Now, Python also allows you to use negative indices to index from a list backward. For the record, Ruby also allows you to do this, but Java doesn't like it. So, there is a difference between the forward direction and the backward direction on Python. Python lists are 1 indexed in the backward direction, meaning -1 gets you the last element in the list, even though +1 gets you the second element in the list. Why do you think that we have 0 indexes going forwards, but 1 indices going backwards? Well, the reason is that we don't really have -0. -0 would just evaluate to 0. So instead, we start with the lists with -1. Let's take a look at how that plays out. So we have a string called spam, and we want to get the last item, M, and then we want to get -2, the second to last item. That's going to be A. And we see that here. Similarly in this list, we want to get the last item, which is going to be 6, and then we want to get the third to last item, which is going to be -1, -2, -3. Is going to be that list of A, B, and C. And we see that right here. Now, finally, we can also use negative indices to update the elements in a list. You'll see that here. If we set the last element to hello and the third to last element to world, then we have this list with the last element set to hello and the third to last element, -1, -2, -3, set to world. Finally, in a tuple, we can get the last item, high, and the second to last item, false, with negative indices as well. Now that's not all when it comes to indexing. We can also use indices to get a specific chunk of any given sequence. we call it slicing. It's a form of sequence indexing where it returns an entire section as a copy of a sequence. The syntax uses a colon, where here we reference the sequence, and then we put a square bracket, and then we put the lower bound. The lower bound is inclusive, which means that our slice will include the item at this index. If you don't specify a lower bound, it defaults to 0. And then you have the upper bound. And that's where you want your slice to end. Now, the upper bound is not inclusive. That item won't be included. If you don't put anything there, then it defaults to the length of the sequence. Now, that can be a little tricky to remember about, because if you put absolutely nothing here, then the last item in the list will be included in your slice. That can be tough to wrap your head around without some examples. So let's take a look. Suppose you have this string, MPCS 51042, this list, Bob, Sally, and Tina, and this tuple, 1, 2, 3, 4, 5. When we fetch this slice, 1:3 of MPCS 51042, what do you think we'll get? We get the second item, that is at index 1, and the third item, which is at index 2, but not the fourth item, which is at index 3. This is what we mean by the initial index being inclusive and the final index being non-inclusive. So now, let's take a look at the same thing for our list, 1 through 3. So it includes Bob. It does not include Bob, rather, because we start at 1 and Bob is at the index 0, Sally, and then Tina. Finally, for our tuple, if we index from 1 to 3, we're going to get, again, the second and third item, but not the fourth, 2, 3. Now, let's take a look at if we were to default some of these. So, let's take a look. Here we've defaulted to getting the second element through the final element of each of our strings. So you'll notice the first element, the first character of MPCS 51042 is cut off, Bob is cut off, and 1 is cut off. But because we haven't put anything here, our slice includes all the way to the end. Now, let's use a default value at the beginning of our sequences. Here, we're going to get everything from index 0 through whatever's on the other side of the colon. We get the first 3 items here, MPC, Bob, Sally, Tina, and 1, 2, 3. We can also use negative indices in our slices. When we do colon through -1, we get a slice of the sequence that starts at the very beginning and goes up to, but does not include, the last item in our sequence. You can think of these negative indices as going up to whatever the length is of the sequence minus whatever the number is for the negative index. So here, the last thing has been cut off of each of our sequences. Now finally, what if we use the default for both? What if we just index on colon with nothing at the beginning and nothing at the end? Well, what that's going to do is create a copy of each sequence, exactly like the original. Now let's zero in specifically on some sequence operations for strings. Python provides us with a collection of methods that can create new strings based on the behavior of the method. So let's take a look at some of those. We have string values, and then we can call functions on them with various different arguments. Let's look at some examples. We have a spam here. We have a string here called spam, and the value is spammy. If we wanted to replace every M with an X, we could use spam.replace. and we see that that prints out our new variable. Remember, our old string isn't modified because strings are immutable, but because we have assigned our changed string to this new variable name, we can still print them out here together. Now, let's search for the index of the first occurrence of spam in this string that has spam in it twice. We can do this with spam.find, and that gives us the index of 4. 0, 1, 2, 3, 4. Now, let's make a list out of this string, where a whitespace character determines where the element divisions should be. So if we do words.split like this, then we're going to get a list with each of the letters separated by whitespace. We can also use any delimiting character that we want inside of split. For example, here, if we put in a comma, then this string will be separated everywhere that there is a comma. Like various numeric types that we've seen, and like the list that we converted from a tuple in a previous example, you can convert various types to strings as well, using the str built-in. We can see here that we've converted these various things to strings, and we can see that their types become string. There are lots of other string methods available to you, but you want to look those up in the documentation. Here we see the official documentation for Python 3 for all of the different string methods that you have the option of using. Now, we'll look at some of the additional mutable sequence methods and operators. These are going to apply chiefly to lists. The reason for that is that lists, unlike strings and tuples, are mutable. We can change them. Here we see assignment to an element, which we've already seen. Assignment to a slice. This allows us to assign multiple elements at once in a list. We can delete a specific set of items with indices from a list. We can replace several items with as many different slice dimensions as we would like. We can also delete with as many different slice dimensions as we would like. We can append an element to a list, which is going to add it to the very end. We can clear a list, which removes all of the items from it. We can copy a list. We can extend a list by adding a bunch of items to the end. Or we can update the list with a repeated version of itself. We can insert an item at a specific index. This is similar to what we're doing up here. We can pop an item off of a given index in a list and remove it from the list that way. Or we can straight up take it out without specifically returning it. We can even reverse a list in place. Let's take a look at some of these. So here we have our list 1, 2, 3, 4. We're going to append high and we're going to append true. And they add those items to the end of the list. Now we can pop an item off of the list, and that gets rid of the true on the end, leaving us with this. Now, there is one more important immutable sequence type for us to discuss, besides the string and the tuple. That's a range. We've left this for the end of this initial discussion on sequences because there's basically only one situation where we're going to be using a range, which is when you're trying to loop through a series of indexes. The range type is chiefly used for this looping practice. Now, there are a couple of different ways that we can define a range. First, we can say that we want to start a range at 0 and then end it at 6. This is going to give us all of the integers between 0 inclusive and 6 exclusive. Let me show you that. So here, when we get the very first index of the range, we get 0. And when we print the very last value in the range, we get 5. This is what our full range looks like. We can define an explicit beginning and end for the range, which essentially works like counting. This is going to give us a range 1, 2, 3, excluding 4. We see that the first element is a 1 and the last element is a 3. Now it's worth noting that printing a range value does not show you the contents. The reason for that is that the values of a range are generated exactly when they're needed for memory efficiency. But you can convert it into a list to see the values if you want to. And the way that you would typically use a range is to loop through a series of something a specific number of times. Let me show you that. So let's say for shout in range 5, we're going to print shout. Now when I run this, shout gets printed out 5 times. 0, 1, 2, 3, 4. This is basically the only situation in which you're going to see a range normally. And so we leave it to the end so that you understand how to use it for that specific purpose. But we'll also be looping through lists later. So you'll get another opportunity to see this for syntax.